Hi, I want to take you through the answers for Module 2, Lesson 3, the practice problems, that is to say. First, we're going to translate these sentences into symbolic sentence. P stands for logic is easy. Maybe I should read the directions. Be a good model. Translate each of the following English sentences into the sentence form that most nearly captures the meaning of the English sentence, using the suggested sentence letters and their assigned interpretations. Be sure to use parentheses when necessary to prevent ambiguity. All right, logic is not easy unless symbols can be used. So unless is like a if not. So if it's not the case that symbols can be used, then logic is not easy. So we have if, we use a tilde for not. If symbols can be used is are, then if symbols cannot be used, then logic is not easy. That's what it comes down to basically. Logic is not easy, or logic is easy as P, so we definitely need a not in front of there. That's the tilde up in, it's at least in my top left hand corner of my keyboard. Logic is easy. Okay, let me make this shorter so I can see these symbols more easily. Logic is easy and fun if symbols can be used. So we're going to do logic is easy is P, and it's saying and here. I use the upward wedge because it's easy for me to find. I just press Shift 6. You can also use the dot. That's fine. It's better, really. And if symbols can be used, then logic is fun. We just want to put that in the correct order where the antecedent comes first. Symbols can be used as are. If you're saying if are, then logic is fun. Q. There we go. Let me just make this even. I have to scroll up a lot, sorry. Symbols can be used. Hold on, let me do this so it's all on one page. I think that's going to make it a lot easier. All right, there we go. Symbols can be used, or it is not the case that logic is easy. So symbols can be used as are, or I choose the lowercase v, or it is not the case that logic is easy. So either are or not P. Sorry, I messed up the spacing accidentally. Sorry about that. Okay. Logic is neither easy nor fun. This proposition would be false, but let's put it in the proper format. So neither is going to make this a not, right? And the first proposition is logic is not easy, basically. So it's going to be, say, not P and not. It's basically saying logic is not easy and logic is not fun. So, and false sentence, of course. Logic is not fun. We would need a not. Logic is fun is Q, so we need a tilde Q or a not Q here. Logic isn't easy, so again, logic isn't easy. Oh, there's clearly a typo here. I'm going to have to go to the easy if, and it's got to be an if and only if symbols cannot be used. Okay, so this is going to be a biconditional. You can tell already, if and only if. Logic isn't says there's a not, so we want not logic is easy, so not P. Logic isn't easy, and this is clearly a biconditional, so let's go ahead and put that there, and then we'll see if we need any parentheses. If and only if symbols cannot be used. So we're going to put a not, there's a not here, cannot, symbols can be used, are. So I believe that's correct. Not P, if and only if not are. That looks right. All right, let's go to the next. Use the same. All right, I'm going to copy and paste these right here so I can see them better. All right, not Okay, let's do P is, we need not P and R. So we're going to say P is logic is easy. So we're going to say logic. Oh, let's see. Let's do it this way. It is not the case that logic is easy and symbols can be used. All right, this is going to be a biconditional, so we're going to say if and only if Q, let's start with Q, logic is fun, and the biconditional, right, this double arrow just stands for if and only if, not R. So we want, it is not the case that symbols can be used, or I can just say symbols cannot be used. If symbols cannot be used. Logic is fun if and only if symbols cannot be used. All right, let's just take this a little at a time. P is logic is easy. And we have an or, the downward wedge is or. Logic is easy or logic is fun. And it is not the case, we have a not there, a tilde. It's not the case that P and Q, logic is easy and logic is fun. So logic is easy or logic is fun, but it's basically saying but not both. And it is not the case. So I could put that, but it's not the case that logic is easy and that logic is fun. But what I have now is technically correct as well, I think. I think but is better. But it is not the case that logic is easy and logic is fun. All right, one more. We have if Q, then R, and if R, then Q. Hey, this is a biconditional, right? We can actually just translate this as if and only if. So we could do Q is logic is fun, and we can just put if and only if. Because remember, the biconditional is just saying that both directions of the conditional are true. Logic is fun if and only if Q. Oh wait, I already have Q, sorry. If symbols can be used. Symbols can be used. All right, so hopefully this is just taking you through a lot of practice of trying to look at these symbols and get them in your brain. So the more you do it, I would make flashcards, honestly, with each symbol and just memorize it. All right, let's do construct a truth table comparing the following pair of sentences and indicate whether the two sentences are logically equivalent. So let's insert a table, and we have two prepositions. So let's think about this. We need two columns, and we need the title row, and then we're going to need 2 times 2 rows. So we're going to need 4 rows. All right, so we have P and Q are the two simple prepositions, and then we'll add more columns as we need them. But first, let's just start by getting all the truth combinations. If you remember, we start with the rightmost and we just alternate true, false, true, false. This is just the standard way to make sure you have all the combinations. And then we go one to the left and we do 2 truths and then 2 falses. All right. And now we're just gonna take this apart, starting inside. Oh, well, these are 2 different. I'm gonna put them on 2 different lines, although that's fine. We're gonna do each one of these. So we need to know that if P then Q, if P then not Q, I can already tell you we're gonna need 2 columns to figure out this. I'm gonna go ahead and insert 2 columns. The more you do this, you'll see how many columns you need just by looking, but just add one at a time. We need to start with not Q. We need to know the truth value for not Q to know this whole conditional. So not Q is the truth value for not Q is just going to be the opposite of whatever Q is. So it's false, true, false, true. Is that right? Okay, make sure I don't make a silly mistake here. All right, this is the opposite of the Q column here. All right, now we want to know if P, then not Q. It's probably better if you keep the capitalization consistent, but it's, it's fine in these cases. I'm not going to take off for that. All right, so we want to know when the P column is true, is the not Q column also true? Well, in this one, if the first one, P is true and not Q is false, so the conditional will be false. In this one, they're both true. And now in this one, we have the case that P is false. When the antecedent of a conditional is false, the overall conditional is just true by default. So those last two rows are going to be true. All right, now column to the right, we want to know the truth value of this. I can tell you already, we are going to need two columns here. Let's start with the if P then Q, and then we'll do the not, that's not, the negation of that, sorry. If P then Q. All right, so again, we're going to look at P and Q here. Whenever P is true, we want Q to also be true. So that's true here. That's false here. And the antecedent here is false, so that's just true automatically. Right? Because we just want to know that when P is true, is Q also true? But we don't care when P is false, whatever. Just automatic. Now we need the not of that. So tilde, if P, then Q. All right. So this is going to be the opposite of this column. So this is false, this is true, and this is false, and this is, this is false. Wait, did I get that right? Yes, I think so. All right. And now what we want to know is, are they logically equivalent? So we need to look at the column that has this, which is the P and not Q. I'm going to highlight that so you can see. Highlight. Like that. And we're going to compare it to this column. Oops. Sorry, they're highlighted in different colors. I should have done that better. Let me try that again. Sorry, it doesn't need to be blue, but whatever, for the sake of time. All right, we have false, true. Oh, no, they are not the same, right? Here it's true and this is false. So these are not logically equivalent. Not logically equivalent. Sorry, I spelled that wrong. Better. All right, I hope this helps.